Yeah, so I'm going to talk about statistics, how to do statistics in Dyalog APL today. So there's two repositories, one to hook into the Python interface, one for the R-Connect, and then you can access all the statistics libraries there. And now I could take some questions. Just kidding. But so why the need for statistics now? Well, if heavily used in rising fields now, like data science and machine learning, where now it's become cool to do statistics again. And if we look at the U.S. Bureau of Labor Statistics, you'll see data science and statisticians, it's one of the top growing jobs right now, and even higher than software developers. But of course, this is a talk on statistics, so the sample size is different in each category. But still, it's something we should be aware of, because I think a lot of this is driven in a shift in company cultures, where companies have now accumulated so much data across almost every single domain, and they're making data-driven decisions now. And there's a whole wealth of information that they can extract from this data, which requires data science and statistical analysis to actually capitalize on this information. And I think this is an excellent opportunity for APL, because a lot of these companies are across different domains, as I said, and they're not necessarily programmers. So, recently I had the opportunity to work with some engineers who were not programmers, and they were involved in this type of work. And then they were trying to do MATLAB, and they asked me for some help, so I was able to help them in MATLAB. And I found that it's easier to convince people to use APL if they're forced to use MATLAB. So, I would show them the MATLAB solution and then say, by the way, this is how you would do it in APL. And then eventually they realized, oh wow, it performs quicker and it's much easier. And I think part of that reason is just because why we see it used in other domains, like in quantum computing, because it's actually an advantage of being an old language. We weren't shackled with the designs of computers. It was just mathematical notation. So obviously things like types and specifying all this information specific to hardware just goes out the window. So it's a really good opportunity to get APL back in industries. And so the first part of data science is always data prep, cleaning, filtering. That part was very easy to do in APL, reading data from different files and databases. But then I noticed where it started to get a little trickier was when they had to do some more statistical analysis or data visualization and different tools. That's where other languages had an advantage because of the sheer amount of libraries they had. So if APL is so well suited, where has this been for so long? I think that might have been one of the problems, because it's so well suited for describing statistics. When we first start off teaching APL, we start with the classic sum expression, and then you could extend that to max very simply by replacing the function. And then you get min, the range is very easily defined, and the mean, that's the wrong definition, but the mean is another very simple function here. So maybe because a lot of it you were able to do so much very simply with APL. And then one of the most hottest topics right now in data science is regression, which is something that's been in APL for a while now, but it's seeing a big comeback. And one way to explain this, when you first start learning, you have a function in x and you're trying to solve. In school you learn to solve for y with the function in x values. That's the first thing you learn. Then you get into algebra, you have y and you have the function, and then you try to solve for x. But with regression, you have y and x values and you're trying to find the function to describe it. So this is an interesting way of explaining it that Dr. Stephen Mansour uses, and I thought that was a really nice way of explaining regression. And just to explain it a little more, basically how it works is if you have several points, I'm sure most of you know this, but just to describe it, we try to find a line that best describes them. So we put a line down and then see how much the residuals are, the distance from our points to our predicted line. And then we could shift that a bit and see if we've shortened the length of all the distances. And we keep going until we find a line that minimizes the distance. So this is what the domino operator does for us in APL. And of course, you can get pretty far with it. I mean, you can actually find the mean of an expression with this, because if you have just a vector of x values, the best fit line through just that is the mean. That's the best fit to describe it. Then you could do linear regression, very simply. And the result of the domino operator are the coefficients that you would do a plus dot times on the right argument to domino to get the estimated value, predicted value. And then you can even do quadratic regression in cubic, and then more generally, just polynomial regression of different degrees. So you get quite a bit right out of the box with APL. But then when it's hard to find a good diagram that explains all of the different categories of machine learning, but this is kind of interesting, and you could see well, you could see in the top right corner here, regression is a big part of this, and all the different types we've seen already come with APL. But then there's a lot of different other algorithms that we should probably look to include in APL, and I think it can be done. And this is, it's still missing some stuff for machine learning, but it gets the point across. So do we have any open source libraries in APL? Well, I want to talk about KokoStats. So this is from Dr. Bill Koko. He was a chemical engineer, and he's developed a toolkit for statistics that he recently gave to Dyalog to open source. So that's what I've been working on, open sourcing that, and I hope to get some contribution on that and help and people to play around with it. And then we have Stephen Mansour, who is a professor of statistics, and he's been working on TamStat for a while. I think a lot of people here are familiar with that, but now it's actually, I think it's going to pay off having this library in APL. And now we've open sourced it. So anyone who's using Dyalog APL can pull it down from GitHub and use it in their projects. So I'll start by showing KokoStats. This is, it's on GitHub now, and you could see some of the functions we have on here, the topics that it covers. It has some basic stuff that data scientists would expect a language to have. And documentation here, you could do things like principal component analysis and a whole bunch of other functions. Yeah. So this is just showing one library and different types of regressions and things you could do. So I'll show an example of that. I'm going to open my APL session.
That was TamStats?
No, that's KokoStats. I'll show TamStat later. So both of these have just been uploaded to GitHub very recently. Is this font size smaller? Let's see. I'll do one more. So what I'm going to do is open a project, and Morton spoke about projects, and once you start using Link, you should look into using a project management like a Citer, or this is data, which allows me to have I only have 9 functions in this Dyalog 23 project, but it's loaded in all these dependencies that I specified. So, KokoStats, the TamStat core, and a little bit of visualization. So I'm going to move in here, and then what we're going to do is we're going to continue looking at this regression example. So if I have basically a data set, I'll call this W, and in it is a matrix of just wine data with a bunch of different properties here. And what we want to do is, they gave it a ranking here for the quality of the wine. So we want to see if we can create a model to use some of these and predict wine quality just by these other variables. So one way we would get started by doing that with this library is, the first thing you want to do is, this is a reference to KokoStats. and there's a function to do a correlation matrix. So this is very simple, but now we could see how all the variables interact with each other. And data visualization is also key for this, so we're working on a library that Richard Park will talk to you about, which is just a call to this Vega Lite library, and then I format the data in the way it expects it. But I can run this, and you could see that, well, hang on. Of course, demos, okay, oops. But you can see I get a very quick description of how these variables interact with each other. So then if I want to look for, a type of linear regression, I can look at this quality row here and see that we see that alcohol affects it a bit. And we also see, we can look for other things that volatile acidity seems to have a high impact as well. So if we want to make a regression model, we also have a function in here to do this. So we'll try this, and it takes a y and then what we try to predict and then what variables we give it as 2 arguments. So this w is a namespace, so it just has a helper function to get columns. So we could say we're trying to predict quality, and then we'll try something, 1 column here. And this takes a vector, so we'll enclose it. And okay, that returned. It returns a namespace back, and we can look at what's inside of it. So we have all this stuff. So when you start doing it, you want more than just the coefficients you get from Domino. So these libraries come and give you a bunch of statistics you can use to see how well your regression performed. So here, most people are familiar with the R² value, and this is pretty low. We didn't do a very good job with this 1 variable. We got 15% of the variation explained. So we can come back up here and we can add another column. We remember that alcohol played a role, so let's add alcohol here. And look at the statistics again. And you can see that kind of doubled the prediction power here. And it was still not that great. I think there's another method for predicting wine quality that we'll show you tonight at the banquet dinner, but not now. This wasn't so good. But other examples you can look at. So if we were looking at student performance data, here's another variable we have. And this is, we want to predict, can we predict how well they perform based on these variables? So the same type of thing you want to do is you want to do a correlation matrix. And then visualize it. And then you could see that we could ignore a lot of these other variables. Our study seems to have a role, and previous scores plays a big impact on this. Another thing you want to do is, this correlation works for these linear relationships, so we could verify that by running another function. So we could look at a scatter plot and a scatter plot matrix on this data. And then we can view how, look at all the relationships very easily. So performance index, we could see, wow, yeah, there is a pretty good relationship with their previous scores and how well they perform. So we could come back and do the same type of thing where we run a regression test on their performance index, and then we can also give it the column of previous what was it called here? Previous scores. And we'll try it with that. Look at the statistics here. And you see we got a pretty good R² value here of 84%, but can we improve that? We can add another variable that we saw that our studied seemed to have an impact as well. So we can combine both of these and look at the statistics we get from this namespace. And we've got a pretty good prediction power there. So also we can look, let me assign this result, because we have other information here, the residuals table, which tells us, we had a 99 was their previous score, and the actual, what they scored on this test was 91, and we predicted that, they would get a 91.1 based on that plus the hour studied. So, and we could, use this has a lot of good stuff to analyze how well we're doing and what outliers impact the data and so on. Also other things like analysis of variance table and so on. So that's, I think that's enough on regression here. Oh, we also have the coefficients, obviously, that we would plus dot times a row of the X matrix to get the prediction. And, okay, let me go back to the PowerPoint. So this is also available in TamStat. So here's an example of using regression in TamStat. You get very similar results. You could see the equation it came up with and other information. So you could use either library, whatever you prefer. And there's also changes being worked on in TamStat, and regression is being turned into an operator. And right now they're exploring different ways to represent the different types of regression as function and operator combinations. So this is still being worked on, and there's still room to grow in both libraries. So I'll talk a little bit about TamStat now. What it is, just very basically, it's another statistical library, and the point of it is, so this example here, we're trying to find the normal probability in a population with the mean of 120 and a standard deviation of 25. So you want to check what's the probability that you would find a value greater than 150 here. So this is how you would express this problem in different languages. In Excel, you have norm.dist and different parameters. And then in a lot of these libraries, you have many functions that expand out to many functions. So you have one for normal distribution, you have one for, the critical value. But TamStat, the idea is you would have a small set of functions and then a small set of operators that can combine in different ways. And it reads pretty English-like, so that's one of the benefits of using this function and operator approach. And some other stuff that you get with TamStat, summary wizards, probability wizards, and a lot of basic stuff that you'd expect in a stats package are now available to you out of the box when you have APL now if you pull this package. And it's been used for years now to teach students statistics, and so it's gone through more testing than the other library has, than KokoStats. So I'll show an example. We'll go back here. So I loaded these libraries in. Now I'm going to start TamStat, and I run a setup command. And right now this currently uses quad path, which I know is a bad thing, and hopefully that'll get fixed soon. But for right now, I'm just going to use quad path. So I could do that example, or I want to do the normal probability, greater than 1.65, and I get this. The functions are in my APL session. Another cool thing I'll show an example of with TamStat is you could do random variable generation. So if you give it a distribution, you want to generate random variables according to. So here's 10 random variables that are uniformly distributed, and I could set a number here to tell what to go up to. So here's 10 numbers, 0 through 9. And there's also, you get a little bit of graphing here, so I could do a histogram, show, and you could do a little ASCII visualization if you don't like JavaScript. But so this is with 10, and you can see as I increase the amount, you start to see the uniform distribution of these random variables, right? And then, of course, you could change this to any other function. So if you want to generate it according to the normal distribution, you could see the bell shape curve there. So this is quite useful to generate random variables. Another thing, let me show, there's also a front end to TamStat. I'll load that in. This is written in DOI. This is a Dyalog user interface. It was formerly known as My Server, so you can describe web pages using APL functions. So here I'm going to run this. I'm going to point to the path here. And this is going to open up an HTML renderer window in developer mode. Let me close this. But you can see this is completely controlled from APL, this user interface. It's a desktop application. This was written by Michael Bass. So you get the same kind of session here and the same thing we were looking at. So you get some autocomplete. And I have this user interface that's available to me. Some other things like we looked at, there's the distribution wizard if you want to play around with different distributions. Which is really helpful for when you want to learn how to do different types of TamStat expressions and learn the syntax, because you can use the wizard to create expressions and then see what the syntax is up here and play around with this and run this. Other interesting thing, there's a lot of interesting things here, but we could do, let's see, confidence intervals. So if I have a data set here, let's see, I can see, I could pick something here from data I've imported with the mean confidence interval and run this. And you get some descriptions of what the spread of the data looks like with different confidence intervals. Yeah, there's a lot of things on here, and I think that's what I wanted to show. If you're interested in getting this front-end user interface, then please reach out to me or Dyalog, and we're still working on a way to package this for users. But the other libraries are on GitHub, so you could check them out. We'll have links to these, and this is pretty recent, but so it's not as complete with documentation and other stuff, but everything's out here for you to pull and play with. Thank you.